Hi everyone, I hope you are doing well. In today's video, I present Gemini, a family of multimodal models released by Google DeepMind and which are considered as the most performant LLMs at the time of preparing this video. Before diving deep into technical things, let's see what Gemini is able to do. So if we start with this experiment presented in Google's demo, by drawing a duck, the model recognized a bird in the beginning by saying the bird is swimming in the water, it has a long neck and beak, and conclude that it was a duck. The model is able to translate the word duck in many languages, like pato in Spanish and canard in French. Also, as we see in the third picture, the model was able to tell how to pronounce it in Mandarin. And in the last picture, when the duck was put in the middle of the ocean, the model recognized that it was a strange situation as there was no land nearby for the duck to rest or find food. Another experiment related to our friend the duck is that the model was asked which path the duck should follow, and the model says it's better to make friends than foes, so the duck should go left. The model has been tested on the cup and ball game as well, and it was able to find the right cup each time, even after shuffling the cups. In the connect dots game, the model recognized the picture of the crab even before starting connecting the dots. Here is another problem example that needs logic. The model deduced which car would go faster based on its aerodynamics. Another amazing example where in the first picture the model recognized an electric guitar. Once an amp is added to the guitar, it recognized it as well the first time and started playing loud electric guitar music later. The model added drums sound to the music when drums were added, as we see in the second picture. And in the third picture, the model recognized that a palm was added and it added beachy vibes to the music. In the next example, the model was asked in the first picture which roller coaster was more fun, and it answers the one on the right. And in the second picture, it was asked to produce a sound that the player would make, and the model says, "What about the woohoo? Amazing, isn't it?" Apparently, the model has knowledge about the planets as well, as it recognized that the planet's order in this picture was wrong and the correct one was Sun, Earth, and Saturn. The model is good at the guess game as well, as it asked the user to find the country home of the kangaroo, the koala, and the Great Barrier Reef, and the player guessed that it was Australia. Apparently, it's good at geography as well. The model is able to recognize scenes from movies as well, like in this example where it was able to recognize a famous scene from Matrix. The model is able to predict the next scene starting from a scene given by a user, like here the model predicts that the cat is going to jump the wall and stick the landing. I don't know about you guys, but this model is driving me crazy. Let's take some examples from the Gemini paper now. I will put links to the paper and to Gemini description page, guys, in the video description. Now, based on this example, the model is able to understand the humor, and it explains that the meme is about a person who is playing a game at 300 FPS, but the monitor is only at 75 Hz. The person is trying to catch the game, but it was too fast for their monitor to display. The meme is funny because it's relatable to anyone who has ever played a game on a monitor that is not fast enough. I hope you liked the meme, by the way. I liked it, honestly. It happened to me in the past. Another amazing example, guys, which shows that the model is able to understand and analyze the video and provide recommendations on how the action in the video could have been better, as we see in the model response saying that the soccer player needs to work on their ball striking mechanics. Their foot is not making good contact with the ball, which is causing the ball to fly up and away from the goal. They also need to work their body positioning. They should be leaning into the shot with their non-kicking leg in the front of their kicking leg, and they should be following through with their kicking leg. I will put the link to the video in the video description as well. I don't know about you guys, but after seeing this functionality, I decided to engage Gemini as a soccer coach. Here is another example where the model processes text, vision, and audio and reason across these sources of information to guide the user in preparing an omelette. As you see in the first picture, the user shows the omelette ingredients and asks, "What's the first step to make a veggie omelette with these ingredients. The model answers, crack the eggs into a bowl and whisk them. In the second picture, the user shows the actual state of the omelette and asks if it looks ready. The model answers, it looks like it's almost ready. You can flip it over to cook the other side. In the third picture, the user shows the final state of the omelette and the model confirms that all is good. This is mind-blowing, guys, isn't it? Another crazy example is that the model was able to recognize precise location where an image was taken, which is New York City in this case, based on visual cues by recognizing the Empire State Building, in this case visible in the background, the 8th Avenue in the foreground, and West 34th Street as Cross Street, even if these cues are with small levels of visual distortion. In this example, I present an example of image generation where the model was given in the beginning 2 colors of yarns and was asked what could be done with them. In the second step, the model was given another 2 colors of yarns and was asked for ideas that could be done with these colors. As we see in the right side of the picture, the model generated avocado with pink seed, not perfect for the seed color, but it hasn't brown color either. And it generated as well a green bunny with pink ears. Another example that I would like to add here is how Gemini was able to update a database based on new information. In this example, Gemini was given a dataset of relevant information extracted from scientific papers. In the first step, Gemini was asked in a prompt to look for more recent papers that are relevant to the study. The model was able to distinguish among hundreds of thousands of papers the ones relevant to the study and the ones which are not. After that, from the relevant papers, the model was asked in a prompt to read the papers and extract the key data. Once it's done, Gemini was asked to update the original dataset with the new data. And here in the first picture, we present an example of the new updated dataset. After that, Gemini was given the graph related to the original dataset, and it has been asked to generate the code that plots the graph. Once the code generated, the code has been used to update the graph based on the updated dataset. The second picture shows both graphs, the original one and the updated one. This is amazing, guys. A use case like this would have taken scientists too much time to collect new data, extract information, and update the old information. Now, guys, it seems that Gemini is good at geometry as well. As we see in the example, the model goes through necessary reasoning steps to find the height of a parallelogram despite the slightly unclear instructions. Gemini is good at solving calculus problems as well. As we see in this example, the model is able to get a solution to the provided calculus problem with a step-by-step explanation and correctly defined lattice equations. Another mind-blowing example here, where the model is able to verify a student's solution to physics problem. The model is able to correctly recognize all the handwritten content and verify the reasoning. On top of understanding the text in the image, it needs to understand the problem setup and correctly follow instructions to generate the answer. As a result, Gemini's multimodal reasoning capabilities made the model to become able to understand the messy handwriting, correctly understand the problem formulation, convert both the problem and solution to mathematical typesetting, identify the specific step of reasoning where the student went wrong in solving the problem, and then give a worked through correct solution to the problem, and it's able to give practice exercises as well. Now let's dive deeper, guys, into Gemini. So the questions that we should start to ask here is, what is Gemini? Gemini is a family of multimodal models trained jointly across image, audio, video, and text on a dataset that is both multimodal and multilingual from web documents, books, and code, and it includes image, audio, and video data. This makes the model able to take texts, audio, images, and videos as input, and to produce textual and image outputs. And last but not least, authors apply reinforcement learning with human feedback to fine-tune the quality and avoid hallucinations. Now, regarding the model size, Gemini comes in 3 different sizes depending on its usage. Gemini Ultra, which is the biggest and the most advanced model. This version is oriented to solve problems with high complexity. Gemini Pro, which is conceived to be scaled easily for different tasks, and Gemini Nano, which is a small efficient model conceived especially for smartphones and other devices applications. Concerning the performance, Gemini Ultra achieves a new state-of-the-art results in 30 of 32 benchmarks authors report on from academia and industry, covering a range of language, coding, reasoning, and multimodal tasks. And the good news are that the Nano and Pro versions are available on Google Cloud from the December 13th, but Ultra won't be available till additional safety tests are done. Now let's move guys to some evaluations. Gemini Ultra is the first model that attained a score above 90% to outperform human expert performance on MMLU, which is gauged at 89.9% by the benchmark authors. Knowing that MMLU is a prominent benchmark for testing knowledge and reasoning via a suite of exams across a set of 57 subjects, and it outperforms all existing models on the same benchmark with the prior state-of-the-art result at 86.4% achieved by GPT-4. Another great thing about Gemini Pro is the fact that it powers AlphaCode 2, which improved 1.7 times its predecessor, evaluated on 77 problems of Codeforce's platform. Another thing, the model achieves strong performance across a diverse set of tasks, such as answering questions on natural images and scanned documents, as well as understanding infographic, charts, and science diagrams. Now, as we see in the table, apart from the MMLU benchmark, Gemini Ultra outperforms all the other models as well on maths, coding, reading comprehension, and machine recognition tasks, except the common sense multiple choice questions where GPT-4 has a better performance. In the next two tables, we see that Gemini Ultra outperforms all the presented models on WMT23 translation benchmark, except GPT-4, which surpasses it into English translation, and the model outperforms all the presented models in multilingual math and summarization as well, except PaLI-X, which surpasses it on Wikilingua. In the next table, we see that Gemini Ultra consistently outperforms existing approach even in zero-shot, especially for OCR-related image understanding tasks for natural images, text, documents, and figures without using any external OCR engine. Now, if we take MMMU dataset only, we see that Gemini Ultra outperforms GPT4-Vision in each discipline except science, and Gemini Ultra outperforms Gemini Pro and Google PaLI-X on multiple lingual image understanding when benchmarked on a subset of languages in XM3600 dataset, except on English where Gemini Pro outperforms its bigger version. Gemini Ultra achieves state-of-the-art results on various few-shot video captioning tasks, as well as zero-shot video question answering tasks as shown in this table. And in audio understanding, Gemini Pro significantly outperformed the USM and Whisper models across all ASR and AST tasks, both for English and multilingual test sets. And in the last part of this video, guys, I present factuality mitigations, where we present the impact of instructions tuning on the rate of inaccuracy, presence of attribution, and the rate of accurate hedging. To give more info, guys, about these sets, the factuality set is an evaluation set containing fact-seeking prompts. This is evaluated via human annotations who fact-check each response manually. We report the percentage of factuality inaccurate responses as judged by annotators. For the attribution set, it's an evaluation set containing a variety of prompts that require attribution to sources in the prompt. This is evaluated via human annotators who check for attribution to sources in the prompt for each response manually. The reported metrics is AIS. For the hedging set, it's an automatic evaluation set where we measure whether Gemini models hedge accurately. We compare Gemini Pro with a version of instruction-tuned Gemini Pro model without any factuality-focused adaptation. We observe that the rate of inaccuracy is halved in the factuality set. The accuracy of attribution is increased by 50% from the attribution set, and the model successfully hedges 70%, up from 0%, in the provided hedging task. Now, before finishing the video, let's present some limitations related to the model. In the first place, authors mention that research and development are still ongoing on hallucinations generated by LLMs to ensure that model outputs are more reliable and verifiable. LLMs also struggle with tasks requiring high-level reasoning abilities like causal understanding, logical deduction, and counterfactual reasoning, even though they achieve impressive performance on exam benchmarks. Now, let's wrap up everything. Gemini is a new family of models which advance multimodal models capabilities in text, code, image, audio, and video. Gemini Ultra surpasses a human expert performance on the exam benchmark MMLU, scoring 90%, which has been a de facto measure of progress for LLMs, even since it was first released in 2020. In the multimodal domain, Gemini Ultra sets new state-of-the-art on most of image understanding, video understanding, and audio understanding benchmarks without task-specific notifications for tuning. And last but not least, the new capabilities of Gemini models to parse complex images such as charts or infographics, reason over interleaved sequences of images, audio, and text, and generate interleaved text and images as responses, open a wide variety of new applications. This is it, guys, for today. Thanks for watching. I hope you liked the video. Don't hesitate to put thumb up if it's the case, and please don't forget to subscribe to the channel to have more videos like this one. Don't hesitate to put a comment if you need more details on any concept about which I talked so far, and see you next time.